Hello, this is Mr. Waters, and this is another video to help with your homework, and this is about some of the problems on page 789. On these, you're finding the sums of series that have got more complicated rules, and so there's a little more work involved with getting to the sums. A little more, but not much. Okay, we're talking about a series that looks like this, say. From 1 up to, let's pick up number here, 5. And let's say 5k to the third power. Okay? Or how about this one here? From 1 up to 50, this one, 2k squared minus 3k. Okay? Now, of course, on these, you could go ahead and just plug the numbers in. You could find, for example, in this one, you could plug 1 in for k and get the value, and 2 in for k and get the value, and 3 in for k and get the value, and add them all together. And that's not too bad, because there's only 5 of them. But this one over here, you can see, we're supposed to add up 50 terms. And so we'd have to do 2k squared minus 3k for k equals 1. And then 2k squared minus 3k for k equals 2, and so on all the way up until 50, and then add them all together, and that would take a half an hour. And really, there's got to be some easier ways to do that. Okay, so how we're going to do that is we're going to make use of some of the properties of sequences and series. Now let me scroll down a little bit here for a second, and what I'm talking about are these formulas here that we had from our book. Okay, and you can see here, notice that I see this kind of overlapping our problems. I'll get this out of the way in a minute, but we're going to use these problems here, these formulas here. We're going to use the top half, our properties of series, and what they allow us to do is take a more complicated formula and break it down into a simpler formula. Okay, which is going to be useful for our second example. And then these down here, these formulas down here, are some formulas that we can use for common different kinds of sequences. So for example, up here, notice that in the first one there's going to be a k cubed, and actually I think I just drew right over the k cubed. Okay, so we're going to use this formula right here. Okay, this formula right here. Okay, so k to the third power, I'm going to put it over here, a sequence with, that's not very good, let's make that kind of look like a sigma. A sequence with k to the third power is equal to n, the number of terms in the sequence, times n plus 1, all divided by 2, squared. Okay? And this one, for the second power, k squared, I'm just going to write it over here, that's equal to n times n plus 1 times 2n plus 1. So we can continue to look at it all over 6. Then the k formula for sequences involving k is just n times n plus 1 divided by 2. Okay, so here we're going to go ahead and we're going to hide those set of formulas again. Okay, but actually before we do, notice, for example, we're going to use this formula here. Let me erase, see if I can erase this now that we don't need it anymore. Let's see where I'm looking. Let's get that out of the way. We're going to make use of this formula right here, where if we've got a constant on the inside of the series, we can divide it onto the outside. We can make use of these formulas here, where if we've got two separate sequences, we've got an addition or a subtraction inside the series formula, we can divide that into two simpler series with additions and subtractions. Okay? Anyway, so let's hide that layer there, and we're going to go ahead and we're going to work on this first one. Okay, the first example, let me erase this here so that we've got more room. There we go. It's a little neater. Okay, so first off, we see that this is a constant on the inside, so I'm going to factor that baby to the outside, make it 5 out there. It's really crappy sigma. K cubed, and we see that that's in from 1 to 5, so we use this formula here to find the K cubed. N is equal to 5 in this case, you understand, because we're adding the first 5 terms in the series. So 5 times 5 plus 1 divided by 2 squared. This is 6, of course. 5 times 6 is 30, divided by 2 is 15, right? And then that's going to be squared. And this is, since we're multiplying 5 here, we can't forget to multiply the 5 on the outside. So this is going to be, getting my calculator out because we're going to need that in a minute. Okay, 15 squared is, of course, 225. So now we just do 5 times 225, which is 1125, and so that is the sum of this series, as you can see right there. So we factored this 5 factored to the outside, then we used the K cubed formula down here, and then that gave us 15 squared. 15 squared is 225 times 5, 1125, and that's it. Okay, now the second one we're going to use is on our second example right here. I'm going to I'll use blue and kind of squeeze it in next to the other one here. I'm going to divide that into 2 separate sequences, okay, that are subtracting. So it's going to be from 1 to 50 of 2k squared, and then minus from 1 to 50 3k. Now we deal with those 2 separately. In both cases we factor the coefficient out. 1 to 50 of k squared minus 3 times 1 to 50 of k. Okay, now we'll just scroll down a little bit here. I may have to move the work down a bit, give us more room down here. I'll scroll down just to there. Okay, let's go ahead and get this out of the way, erase that. Okay, so now the k cubed up here, you can see we're going to use or the k squared, I mean, we're going to use the k squared formula. So that's going to be 50, which is n, times 50 plus 1 times 2 times 50 plus 1, right? And all of that divided by 6, and that's the k squared, you understand. And then all of that times 2 to give us the times 2. Now to get the second part, the 3 times k, from 1 up to 50, that's going to be minus 3. And now we're going to use the k formula. N is still 50, so 50 times 50 plus 1, all divided by 2. Now we really just let the calculator do the rest. That, of course, is 51. That's 100. Plus 1 is 101. So we are doing 50 times 51 times 101, all divided by 6. And then, so that's, according to my magic machine, that is 42,925 times 2. Scroll down again here. Okay, so times 2 is 85,850. Okay, minus, okay, so up here, this of course is 51, so we're going to do 50 times 51 divided by 2. So now we've got 3 times 1275 times 3, that's 3825. And now we do the subtraction. And that's 8225. So you see the plan here is we take this complicated series, sigma series thing, and we divide it into 2 separate pieces, subtracting right there. And then we factor out the constant, brought those out there, and then we just use our formula to actually figure out the sum, the k squared and the k formula. And then as long as we can push the correct buttons and put everything in the right place, we end up with the final answer down at the bottom. Anyway, thanks.